Thank you for joining Geometry Notes Made Simpler. Today we are going to look at the right triangle. And I always say, when we are studying math, it's always good to create you a note page of all the equations you're studying and at least one example equation that goes along with your directions. That does make it easier when it comes to preparing for your exams. Help you stay in the 90% or better range to keep up with that A. So with that being said, let's look at the right triangle. We're going to look at naming the sides, solving for missing angles, and finding the sine, cosine, and tangent of an angle. Okay, what we do know about triangles is no matter what type of triangle it is, all angles will always add up to 180 degrees. No matter what type of triangle it is, all three angles will always add up to 180 degrees. Okay, we're going to look at the right triangle, and we know that is different because that's the one with the little square in the corner. That square represents the 90-degree angle side where the vertical and horizontal meet. So, because three sides of a triangle, very easily using the algebraic equation to find the missing side, because A, B, and C will always equal up to 180. You usually given equations like this. If A equals 40 degrees, what does B equals? Very simple, plug in what you do have. 40 for A plus B and 90 for C. And that equals 180. Combine like terms, which is the coefficients. 190 and 40 is 130. So bring down the B plus 130 equals 180. Now, next up, move your coefficients, separate them from the variables by moving the coefficients to the other side of the equal sign. And you do that by taking the opposite. Opposite of 130 is negative 130. If you take it from this side, you must also take it from the other side of the equal sign. So, when solving for that, you bring down the B. 130 cancels out with the negative 130 equals 180. Take away 130 is 50. So B equals 50. Very easy way to find the missing side of any triangle. Put it in algebraic form, label them A, B, C, plug in the angles that you do have, combine like terms, solve for your missing variable. Now let's name the sides of the right triangle. We know the slanted side of the right triangle is called the hypotenuse. The slanted side of the right triangle is called the hypotenuse. And the side of the right triangle that has the angle you're looking at and the 90-degree square, the side of the triangle that has the angle you're looking at and the 90-degree square, that side is called the adjacent side. The side that has the angle you're looking at, which we call that angle theta, angle we're looking at, and the 90-degree angle. The side that shares both of those, that is called the adjacent side. And the side that is opposite of the hypotenuse, the side that is opposite of the hypotenuse is simply titled opposite side. The side that's opposite of the hypotenuse is simply titled opposite side. Now, when you have an equation where you're solving for the length of any one of these sides, very easy to use the Pythagorean theorem. In Pythagorean theorem, make it very easy to solve for all three sides. A squared plus B squared always equals C squared. Whatever A is, square it. Whatever B is, square it. Add them two together. That answer will always equal C squared. So how do you get C? You take the square root of your equation. You squared them, added them up. Whatever that answer is, you took the square root of it. When you take the square root of your equation, It removes the square from the C. See that? Okay, and you're usually given this in like a word problem. So let's look at this word problem. If a 17, let's look at this word problem. If a 17-meter piece of string was stretched from the top of a 15-meter pole down to the ground, if you stretch the string down from the top of a 15-meter pole to the ground, it's 17 meters. How far would the distance be from the bottom of the flagpole to the bottom of the string? To the bottom of the string, or the base of the string. What is that distance? That distance is your B. So let's plug in what we have. A is 15, correct? So that's 15 squared plus B squared equals C is 17. So that's 17 squared. Calculators are very good for your square root, for your squares and your square roots. Want to know the square of a number? Punch in the number and push that button on the calculator to give you the square of that number. That's that number multiplied with itself. Or if you want the square root of a number, type in the number and then push this button here to give you the square root of that number. So, with that being said, it's 15 squared is 225 plus B squared equals 17 squared equals 289. Next step, always separate the coefficients from the variables by moving the coefficients to the other side of the equal sign. Do that by taking their opposite. 225 opposite is negative 225. If you take it from that side, you must take it from this side of the equal sign as well. So 225 cancel out with negative 225. Bring down the B squared equals 289. Subtract 225, 64. B squared equals 64. What are you to do when you have the square of the square answer? You take the square root to get your B, your square root to get your variable. So the square root of 64 is 8 because 8 times 8 is 64. So the square root of 64 is 8. That equals B. Very simple. Now, what if the flagpole was only 3 foot and the distance from the flagpole to the string was only 4 foot? Then how long would the distance of the string be? Very simple. Let's plug in what we have. A equals 3. That would be 3 squared. And 4 equals, and B equals 4. That would be 4 squared. 3 squared is 9 plus 4 squared is 16. 9 plus 16 is 25. How do we get C? We take the square root of our equation. Take the square root and we will have C. So the square root of 25 is 5. 5 equals C. Very simple. Okay, and because it is so simple to find any side of a right triangle using the Pythagorean theorem, because it is so easy, the Pythagorean theorem here, because it's so easy to find any side of a right triangle using this formula, and because it is so easy to find any angle of a right triangle by using A plus B plus C, since all three angles always end up to it adds up to 180. Because those are both very simple to remember and practice, you are also asked to find the sine, cosine, and tangent of that same angle. Okay? And that's because sine, cosine, and tangent are simply plugging in the answers you already have for your opposite, adjacent, and hypotenuse. Plugging them in a fraction form. It's just that simple. And let's look at how it is done. You heard of the word SOHCAHTOA. Very simple way to remember the sine. What is the sine of an angle? It is the opposite over hypotenuse. C is cosine. Cosine is the adjacent over hypotenuse. And Tangent is the opposite over adjacent, as you can see them right here. So, looking at this angle, we're calling angle theta, and the reason why you have to be aware, and they gave a name to the angle you're looking at, as it is theta. The reason why is because they could ask you for this angle instead of that angle. And if you are asked for that angle, what is the sine of this angle right here? Then you have to remember the rule for the adjacent line. The adjacent side is the side that holds the angle theta that you're talking about and the 90-degree angle. Meaning, if we were talking about this angle here, then this side will become the adjacent side, which means this side will become the opposite side. You must know which angle you're speaking of so you can properly give the sine, cosine, and tangent of an angle. Okay? So this is the angle theta that we're speaking of in this equation. And the sine for this angle theta is sine over cosine over hypotenuse. And what is that? We see opposite. So the sine of that angle is, opposite is 3, and hypotenuse is 5. Correct? Now, for the angle theta, we see the cosine is adjacent over hypotenuse. That's the cosine. And for the tangent of that angle, we see that is opposite over adjacent. Now, as simple as it is, that's how simple it is. So with that being said, you're also going to be asked to find the cosecant, secant, and cotangent of the same angle, because it is just that simple. You plug in what you see. A cosecant is the opposite of sine, represented by 1 over sine, which means it's reciprocal. Reciprocal, we learn, means flip it upside down. So, if sine is opposite over hypotenuse, then the cosecant is hypotenuse over opposite. Very simple, right? The secant is the opposite of 1 over cosine, is the opposite of cosine, which you write as 1 over cosine. And the reciprocal of cosine is hypotenuse over adjacent. Flip it upside down. Okay. Hypotenuse over adjacent. And adjacent is 4. I was trying to draw a, Lord help. And the cotangent means the opposite of tangent, written as 1 over tangent. The reciprocal, flip it upside down. So that would be adjacent over opposite. See, just that simple. Because it is just that simple, you're usually taught these all at the same time. You're taught how to find your angle of any triangle, simple algebra expression, a plus b plus c. You're taught how to find any side of a right triangle using the Pythagorean theorem, a squared plus b squared equals c squared. And then you're taught how to find the sine, cosine, and tangent of that angle by just plugging in the answer you already found for the Pythagorean theorem. And you're taught, that's why you're taught to find all 6. Just looking at your answer, you can clearly answer all 6. So with that being said, you're also at the same time taught that by giving, they're usually giving you 1 point. And you're usually told to find the sine, cosine, tangent, cosecant, secant, and cotangent with 1 point, because it is just that simple. one thing we know is when you're given a point, your x is your cosine and your y is your sine. So with that being said, your x is your cosine and your y is your sine. So with that being said, let's look at this point here. 3 is x and y is 4. Where 3 is x and where y is 4, this is your point. When you have your point, you draw your line down to your origin from your point. That becomes your hypotenuse. Next step, you draw your line from your point to your x-axis. And that becomes your opposite. That becomes your opposite, which is your sine. That's why y being 4 is your sine. That's your opposite. And your cosine is your adjacent. That's why the x is your cosine. That's your adjacent line. So you have your adjacent, you have your opposite, all from this one point here. You made your triangle, you have all 3 sides. Now you're going to find your hypotenuse. How do you find that? When you have 2 sides, you use the Pythagorean theorem to find your third side, correct? Very simple. So, your A is your opposite, and that side is 4. A squared is 4 squared. And your B is 3. That's 3 squared. So 4 squared 16 plus 3 squared, which is 9. 16 plus 9 is 25. The square root of 25 is 5. Since the square root of 25 is 5, C equals 5. There you go. This is 3, and that is 4. We have our 3 sides. Now that we have our 3 sides, we can now plug in for sine, cosine, tangent, secant, cosecant, cotangent. All 3 sides are right there. Very simple to find. Now, that being as easy as it is, it's also why you are taught as well the 1 unit circle. Because if you focus in on the 1 unit around of the quadratic chart we're looking at, 1 unit up, this is that's the point 0 for x and 1 for y. 1 unit to the left is -1 for x and 0 for y, because you're on the x-axis. 1 unit down on the y-axis is 0 for x and -1 for y, because you're on the y-axis. And 1 unit to the right is 1 for x and 0 for y, because you're on the x-axis. That's these 4 points right here. Okay? That's these 4 points. So, if you took a line, connect your dots, starting here, you'll have one complete circle. The full circle is 136-degree angle. The complete circle is 136 degrees. Half of that circle is your 180 degree, which is your x-axis right there. Okay? With that being said, if you took your compass, put it right on the origin there, and drew a line from the origin to the 30-degree angle up till it touched that circle point, it would hit that circle point right there. And if you took a line and went straight down to the x-axis, it would hit the x-axis right at 0.87. 0.87 is the same as square root 3/2. If you took a line from that same point and went straight across to the y-axis, it would hit the y-axis right at 1/2. That's where we hit the y-axis, right there, 1/2. That is why this point is square root 3/2 for x and 1/2 for y. Okay? from the origin, if you went up on your compass on a 45-degree angle till you hit the circle. And from that point, you drew your line straight down. It would hit the x-axis right at point 7. Right there. Point 7 is the same as square root 2 over 2. Point 7 is the same as square root 2 divided by 2. And it would hit the axis there. If you took a line and drew it straight across to the y-axis, it would hit the y-axis, same place, point 7. Okay? That's why for x, it's square root 2 over 2. That's why for x, it's square root 2 over 2. And that's why for y, it's square root 2 over 2. Okay? Now, in seeing that, what we notice about this circle here? What do we notice about the 1 unit circle, 1 unit around? What do we notice about this? If we look at the x-axis, we notice one thing about this x-axis. If we go 30 degrees up on this side, or 30 degrees up on this side, 30 degrees down on this side, or 30 degrees down from this side, coming off the x-axis, if we did that, we're going to always see the same number. Square root 3 over 2 and 1/2, correct? We're going to see the same number down here as we see up there. Same number down here at 30 degrees down or 30 degrees up from 180. Same number, square root 3 over 2. If we went 45 degrees up or 45 degrees down on the x-axis, even over here, 45 degrees up or 45 degrees down from the x-axis, we're going to see the very same number, square root 2 over 2. No matter where we go, we see the same number, square root 2 over 2, 45 degrees down or 45 degrees up. Here, 45 degrees up or 45 degrees down. We see the same two numbers, square root 2 over 2. And at 60 degrees up from 180 or 60 degrees down from 180, same where over here or over there, we will see the opposite of 30 degrees. Same numbers, right? Same three coefficients, square root 3 over 2, square root 2 over 2, and 1/2. 3, 2, 1. Same three numbers we see over and over on this unit chart, correct? And the only thing we notice that changes is their signs. Only their signs change. And what we know about their signs, they change because of one thing, where it is in the quadrant chart. We already know about the signs in our quadrant charts. If the number is in quadrant 1, the x is positive and the y is positive. That we do know. If you're in quadrant 1, the x is positive and the y is positive. If your number is in quadrant 2, your x is negative and your y is positive. Everything over here. If your number is within quadrant 2, your x is negative and your y is positive. If your number is in quadrant 3, your x is negative and your y is negative. If you're in quadrant 3, your x is negative and your y is negative. If you're in quadrant 4, your x is positive, everything over here, and your y is negative, everything over here. We already know that. Very simple. We already know that. So, with that being said, your teacher is going to have you to draw your unit circle. It should not take you any time at all because you already know your three numbers, 3, 2, 1. So as simple as it is, that's how simple it is. You would draw your y-axis, line straight down. You would draw your x-axis, line straight across. Right where they intersect, that's your origin. You will put your points in. Your 0, 1 for y-axis. Your -1, 0 for the x-axis to the left. Your 0, -1 for the y point there. -1 y point there. and your 1 comma 0 for the 1 for the x point there. Then you would just connect your points. Make your complete unit circle. There it is. Now, you put your 3 dots on each side. Your 30 degree, 45 degree, and your 60 degree. 3 even dots. Do the same thing in that quadrant. Your 3 even dots. Same thing in that quadrant. Same thing in that quadrant. What do you know about your numbers that are 30 degrees from your x-axis? Same number. Square root 3 over 2. Put it in on all 4. Square root 3 over 2. You know that. Your 45 degree dot. Same number. Square root 2 over 2. 45 degree dot, put in square root 2 over 2. You know that. And then your third dot, your 60 dot, 60 degree dot. Same thing, opposite of 30. So it'll be 1/2 and then square root 3 over 3. Same thing. Your 60 degree dot, same thing from the x-axis. It'll be 1/2 and square root 3 over 2. After you put your numbers in, those same numbers over and over, then because of the quadrant you're in, plug in your signs. You already know your quadrant signs. Plug it in for each one of them. Now that you have them plugged in, now you can plug in your numbers. You know that's 30, 45, 60. You know that's 90 because that's the 90 degree angle straight up and down. You know that part there. You know 90 more is 130, or you could take it from the 180. When we're teaching this, we prefer to teach you from the 180. 30 degrees up, 30 degrees down, 45 degrees up, 45 degrees down, 60 degrees up, 60 degrees down. The reason why we prefer to teach you from the x-axis is because after you learn this, you're going to learn what's called reference angles. Reference angles is the difference between your angle and the x-axis, which is the 180 degree line. Okay? So with that being said, you might be, when you're talking about reference angle, you might be given an angle of 135 and then asked to find the reference angle. What is the difference between that and 180? That is 45 degrees, correct? So the reference angle on 135 degrees is 45. What is the reference angle on 225 degrees? 225, the reference angle, is also 45 degrees because this is your difference going back to the x-axis, the closest x-axis. Okay, if you're given an angle of 300, what is your reference angle from the angle 300? That would be 60 degrees. Your reference angle from 300 is 60 degrees. Okay? If you're given an angle of 60 degrees, what is your reference angle? For your reference angle for 60 degrees is also 60 degrees because you're 60 degrees to the x-axis. Okay? So that is the reason why we want you to focus on when you're making your unit circle to think of the easiest way of completing your numbers from the x-axis. It'll just help make it easy for you to remember the difference as you study your next step, which is reference angles. So when you going from your x-axis, you're going up 30, you know that is square root 3 over 2, and your y is 1/2. When you go up 45, you know it is always square root 2 over 2. And when you're going up 60, whether you go up or down 60, you know it will always be the opposite of 30, which would be 1/2 and square root 3 over 3. Square root 3 over 2. Okay? So in knowing that, and you plug in your numbers, you know 30 more than 180, 110, 45 more than 180 is 225, and you know 60 more than 180 is 240. You can count from, you know, this is 360. You can do it backwards if you like. 360 minus 30 is 330. 360 minus 45 is 315. 360 minus 60 is 300. However you want to quickly put in your numbers, you can. You have completed your circle. It took you no time. Same 3 numbers over and over again. Square root 3 over 2, square root 2 over 2, and 1/2. 3, 2, 1. No, you would never forget those, so you would always be able to do your circle very quickly. Okay, because these are very simple ways to know how to do your sine, cosine, and tangent after they gave you a point to find your angle. Because these steps become so simple, This here becomes very easy to do, so it's always learned all together at the same time. With that being said, you're usually given things like this here. What is the sine of 300? I apologize. I don't know why it's starting to mess up on me. So we'll do this one. Okay. Now sometimes you're what is that about? I don't know. Okay. I apologize. My pen is acting up. Maybe it's the pressure difference. I don't know. So sometimes you're given. Why is this happening right now? Don't know. Goodness. Okay. So sometimes you are given the sine of 30. What is the sine of 30? Looking at the degrees, the sine of 30 is 1/2. Very simple to do, right? You might be given the cosine of 125. What is the cosine of 225? Very simple. The cosine of 225 is square root 2. The cosine of 225 is square root 2 over 2. That's negative square root 2 over 2. That's the cosine of 225. What if you're asked for the tangent of 315? What if you're asked for the tangent of 315? What would that be? Tangent is the opposite over adjacent, correct? Your opposite is your sine. What is your opposite? Your opposite of 315 is negative 0.7. Because square root 2 over 2 is 0.7. So your opposite is negative 0.7. And what is your adjacent? Your adjacent is your cosine. Your cosine is same thing. But that one is square root 2 over 2, which is 0.7. So with that being said, the tangent of 315 would be what? 7 divided by 7 is 1, but what kind of 1 is it? Negative divided by positive is negative. So the tangent of 315 is negative 1. Just that simple. Okay? This is why when doing these equations, you will be taught all these at the same time. Because even though it seemed like a lot, it's very easy to find any missing angle of a triangle. Set it up algebraic form, ABC, all three angle sides, plug in angles you do have, and solve for the missing angle by algebraic form and solving for your variable. Then learning all three the name of your sides, knowing your adjacent side is the side that holds the angle you're looking at and the 90-degree angle. That verifies what side your 3 points you have, and you use a Pythagorean theorem to find the missing length of any side. Very simple. Once you have that, you take the square root of that answer in order to find your missing side. Very simple, especially when you have a calculator. Punch in, plug in the number you have. They'll give you two numbers. Plug in the number you have, use your calculator to square it, or use your calculator to get your square root. Very simple. Then square root your answer, and there's your answer to the missing side. Very simple. Because it's that simple, you are taught sine, cosine, and tangent at the same time, because all you do is look at your answer and fill in the blanks. You have your answers, so you can handle all 6 side questions, because you already done your answer with the Pythagorean theorem. So now that you have all 3, you can easily plug in what all 6 of these are. And because it's that simple, you will be given a point, and you'll be asked to find all 6 sides from that point, because yes, it becomes that simple there as well. And remember, when you're asked to create your 1-unit clock, make your axis, make your points, connect your dots, then plug in your number. Same number all over again. Put in your 3 dots on each side, plug in your numbers from the x-axis. Same 3 numbers up and down, same 3 numbers up and down. We know what number is in the middle, and we know it's the opposite on the 3rd dot there. And then we plug in our signs for each side. Very simple to do, okay? So, only thing that will become, only for a moment, slightly complicated is when you are given equations like this, and it might have a coefficient in front of it, or one of these might be missing, and you got to find that. It becomes very simple. It's just switching stuff around and plugging in, which I will bring up in the next video. So I do thank you for tuning in to Geometry Notes Made Simpler, and I do look forward to seeing you in the next video. And remember, practice, practice, practice. The math notes can be very easy once you practice the directions. A lot of people feel because I learned the directions, they became so easy so quickly, I don't have to practice for my exam. That's why we don't get the 90% or better in our grades. Because algebra notes, any math notes, is very simple to learn once you practice them. But it takes the practice to learn them to do much faster, which is why you're given so many on exams. Because once you learn them, you have to practice to do them at a faster pace. That is how you get your 90% or better. Learning to do your equations at a faster pace. That is why you're given so many on your exams. It's not the fact of learning the directions of how to do it. It's directions are made very easy for you, so you can learn to do them at a faster pace. The more you practice, the more you can do that, the more you'll stay in 90% or better on all your math classes. Thank you for tuning in to Geometry Notes Made Simpler. Keep your notebook of all your notes, and I look forward to seeing you in the next video. Thank you, and have a good day.